Hey guys, welcome back. So today we will continue with functional programming in the freeCodeCamp curriculum. Before we get started, make sure to click the subscribe button. Okay, so let's get on with it with the first exercise. So first let's look at this concise definitions that freeCodeCamp has put here for functional programming. So it is a style of programming where solutions are simple, isolated functions, okay, without any side effects outside the function scope. There's an input, a process, and an output. So we have isolated functions, pure functions, and functions with limited side effects. Let's see what we have to do in this exercise. Okay, in the code editor, we have the prepare T and get T functions, which are already defined. We need to call getT function to get 40 cups of tea for the team and store them in the T4Team FCC variable. So here we have the function prepare tea. It just returns the string green tea. And here we have the function getT, gets a number of cups. Okay. Now we need to call this getT, but for 40 people. So I think this is very straightforward. GetT and 40. Let's run the tests. Yeah. Okay. Now some terminology. So getT function from the last challenge. So let's see, we need to revisit it. What are callbacks? Callbacks are functions that are slipped or passed into another function to decide the invocation of that function. Okay, so far we have seen that we have seen functions like this passed to other methods, for example in filter. The callback function tells JavaScript the criteria for how to filter an array. Okay. Functions that can be assigned to a variable, passed into another function, or returned from another function, just like any other normal value, we call them first-class function. Okay, in JavaScript, all functions are first-class functions. And the functions that take a function as an argument or return a function as a return value are called higher-order functions. And when the functions are passed into another function or returned from another function, then those which get passed in or returned can be called a lambda. Okay, let's see the exercise. We need to prepare 27 cups of green tea and 13 cups of black tea and store them in these two variables. Okay, the getT function has been modified, so it takes a function as the first argument. Okay, and the data, the number of cups, is supplied to the last argument, as the last argument. Okay, let's see. We have prepare green tea, prepare black tea, and then right here we have getT, which takes a function as a first argument and the number of cups as the second argument. So we want to call getT, but for green tea we need to give prepare green tea, the function, as an argument, and then the number of cups. We want 27 cups of green tea, 27. And now let's copy this and transform it for black tea. So this will take prepare black tea as a function and 13. Okay, let's run this. Yep. Now, understanding the hazards of using imperative code. Okay, so functional programming is a good habit. It keeps the code easy to manage and saves you from sneaky bugs. Okay, so the imperative style of programming is the one that gives the computer a set of statements to perform a task. So sometimes this changes the state of the program, like updating global variables. So the classical example is the for loop that gives exact directions to iterate over the indices of an array. Functional programming is a form of declarative programming, not imperative. So you tell the computer what you want done by calling a method or a function. Okay, so there are many predefined methods in JavaScript that handle common tasks. For example, instead of using the for loop, you could call the map method. So, for example, we are in a web browser and we want to track the tabs that we have open, and we will try to model this using some simple object-oriented code. So a window object is made of tabs, and of course there are more than one. There can be more than one window open. The titles of each open site in each window object is held in an array, and after working in the browser, opening new tabs, merging windows, and closing tabs, we want to print the tabs that are still open. Closed tabs are removed from the array, and new tabs, for simplicity, get added to the end of it. So we have these functions tab open, tab close, and join. Let's see the code. Here we have a variable window, which is we store a function. Sorry, this is a constructor for a window, and we give it the tabs as input. We have a join in the window prototype, which takes another window and concatenates the tabs. The array which contains the tabs. A tab open is a function in the window prototype, which just pushes the string of a new tab into the tabs array. Close does so. Close is the one we need to modify. Okay. So we need to make sure that tab close just removes the correct tab. So here we have a function, we get an index of the tab we want to remove. Okay, so we have this code. This is really confusing. We need to do something really simple here. Let's just remove. We need to change this code. So let's do this. So we want this dot tabs, and we can do splice. We just remove the index, and this is the number. Okay. So in this case, this is what we want to print. Yep. I think this one should work. We just remove the tab with the index given. Yeah, okay. Now, how to avoid mutations and side effects using functional programming. So the issue was with the splice call in the tab close. So splice changes the original array it is called on, so that the second call to it used a modified array and gave unexpected results. Okay. So this is a small example of a much larger pattern. You call a function on a variable, array, or an object, and the function changes the variable or something in the object. One of the core principles of functional programming is to not change things. Changes lead to bugs. The previous example didn't have any complicated operations, but the spliced method changed the original array. Changing or altering things is called mutation, and the outcome is called a side effect. So the function should be a pure function, meaning that it does not cause any side effects. Let's see. We have the exercise here. We need to fill in the code for the function incrementer, so it returns the value of the global variable fixed value increased by 1. We just need to return fixed value increased by 1. try it like this. Fixed value plus 1. Okay, yeah, that's all we need. But we didn't reassign fixed value, we just returned it. Pass arguments to avoid external dependence in function. Okay. We didn't alter the global variable value, but the function incrementer would not work without the global variable fixed value being there. So another principle of functional programming is to always declare your dependencies explicitly. That means that if a function depends on a variable or object being present, then we need to pass that variable or object directly into the function as an argument. It is easier to test the function, you know exactly what input it takes, stuff like that. And now we need to update the incrementer to clearly declare the dependencies. So the dependency is the fixed value right here, and we can just call it a value. We don't care for the name of the argument, and we just need to return value plus 1. Okay, so we declared the input that this function takes explicitly. Yeah. Okay. How to refactor global variables out of functions. We've seen two distinct principles for functional programming. Don't alter a variable or object, create new variables and objects and return them if need be from a function. We need to declare function arguments. Okay, now let's see something more complex than just an incrementer. We need to rewrite the code so that the global array book list is not changed inside either function. The add function should add the given book name to the end of the array passed to it and return a new array list. We need the add function. Okay. The remove function should remove the given book name from the array passed to it. Both functions should return an array and any new parameters should be added before the book name parameter. Here we have book list. We have the function add. It takes the book list and the book name, and we push book name and return new book list. Remove. So here we find the index of this book name, and if that index exists, so it's not -1, we do the splice and return the new book list. Okay. So in this case, book list should not change and still equal. Yeah, okay. So we shouldn't change book list. A new book list should equal to the Hound of Baskervilles. Okay. Here we have new book list, is this one. We just need to add. Let's see what happens when we run this. Okay. We have the book list here. Or let's just do, we have a type error here. This one is really strange. Okay, so I'm just resetting the code here so make sure there's no problem. Okay, now, so this is what the book list is printing right now, but we want it to have, there's one missing. So let's see what happens when you run this. So we need to fill out this requirement. New book list should equal the Hound of the Baskervilles. Okay. So it isn't. So it should have a brief history of time added. Let's console log this new log new book list. We have something here, circular. Let's see. The Hound. Okay. We want to add a book name. So let's declare a book list variable here as an argument. And now what we want to do is push this book into the book list and return that book list. Let's run the test and see if this one is fulfilled. Oh, let's see how this one is called. So when we have this new book list, we call add with the book list and a brief history of time. Okay. So let's make a new book list, a copy of this book list, so we don't modify it. And let's see what this does. Let new or return book list is going to be, and we want to copy book list. I'm using the spread operator we learned a little while ago. And then right here, I'm doing this, pushing, and I'm returning this one. Let's run the tests. Okay, so now we have this requirement. And we have to do the same for the remove. Let's add a book list here. And now let's copy it like we did right here, so that we create this variable which is scoped only inside here. And now I'm going to use return book list. Okay. To use this return book list here. So I just make sure to create a copy. Let's see if this one does it. Yeah, that's what we needed in this case. Let's continue. Now, using the map method to extract data from an array. So we learned how to use pure functions to avoid side effects in a program. We've seen the value in having a function only depend on its input arguments. Now, let's see how to pass a function as an argument. We are going to use the map. The map method iterates over each item in an array and returns a new array containing the results of calling the callback function on each element. Okay? And it does this without mutating the original array. For example, let's see. We have this users array here, and we apply the map method, and we check, and we just return the names of these objects, because this is an array of objects. And in the end, we get this array of strings with just the names. Now, we want the watch list array. We need to use the map to assign a new array of objects with only title and rating keys to the ratings variable. Okay, and the code in the editor currently uses a for loop. We need to replace that using the map. Here we have a list of movies, which are objects, and we just need to grab the title for each one. So, okay, how do we access the title in the object? We just use the bracket notation. We need the title and the rating. Okay. So let's now what we need to do in this case, just use map. Let's call it, we have the variable ratings, and we can do it like this. We're going to do movies. What was the name of the variable? I can't remember. Oh, watch list. Okay, so we're going to do watch list map, and inside we're going to do a movie which maps to another object, and we want this object to be to get the title and the rating. So we want to return something like this. Okay, let's do it. Title, and this is going to be movie. I'm using the bracket notation. Okay. Let's see. And then we want the rating, which is going to be movie rating. Okay. Oh, we need to write this. Let's write it like this. These are properties, so we just need to write it like this. Okay, and let's remove the for loop. So let's see if we have some syntactic error here. No. Okay, so in line 117, so we have this. We want to have title. Let's see. Okay. What does this do? So we have something here. Let's make sure watch list. So the variable is called watch list. It's a list of objects. And now, what if we need this as a string? Maybe we need this string. And I'm going to make this, no, not this one. This one as a string. And this one. Okay, maybe let's try. Okay, let's make this more readable and easier to. Okay, wait, let's to make this. Let's use the dot notation. I want to try this. Okay. Okay, I was writing rating, but this is actually, is there a rating here? No, so I was using the wrong property. This one should be right. So this is IMDb rating, right? Okay. Oh, okay, so we forgot to put this in the parentheses. Okay. Now seems to be working. Yep. Okay, guys, I think we will do one more maybe. Okay, let's do one more and finish this video right here. So we want to, so far we have applied a map on an array. Let's do it on a prototype. Okay, so map is a pure function. Okay. Let's write our own array.prototype.myMap, which should behave exactly like array.prototype.map. And we just use a for loop for, or the for each method. So this is array.prototype.myMap. We have a function which takes a callback function, okay, which we need to apply and create a new array. Let's do a for loop. Let I equal to 0, I smaller than. So we want to iterate through the array, and so in this case we want to iterate the array and we should access the array using this dot length. Okay, I think this one should work. Let's see. So we are iterating through it, and then we check if callback. So we have a function which we apply on this and I. So if this one is fulfilled, then we do new array dot push this I. Okay, let's run this. Let's see what new s. I'm not sure on how to access the array, but let's see. So we are getting again new array, we push. What is the function in this case? Okay, sorry, we just need to push. Wait, this is not filter, I was thinking of filter. So all we need to do is just push this. Okay. Just apply the callback on this. There is something missing here. So this one closes the for loop, and we have one extra. Yep. Okay. I think now this one should do it. Let's run it. Yeah, perfect. Okay, guys. That's it for this video. In the next one, we will continue with functional programming. Before you go, please don't forget to subscribe and hit that bell notification icon. Also, maybe check out my Instagram and Twitter, Facebook as well. Thanks again. I hope this is helpful. I'll see you in the next one. Bye bye.